Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime. And all you need to do is write some JavaScript code and use the real-time web with Node.
You're watching Real-Time Web with Node. This is level 4, where we're going to be talking about modules. So in previous levels, we brought in modules from other libraries so we could use their code. Remember, we used the HTTP library and the FS or file system library. But how does require return these libraries? How does it find these files? And how might we create our own modules so we could share code between different applications? Let's create a really simple module. We'll call it custom hello.js. It has its own file. Inside there, we'll define a function which simply logs out to the console, hello. In order to expose this method, make it public, we need to write module.exports equals hello. Then, inside of our application file, we can write var hello equals require custom hello. Notice we have to do that /. I'll explain why later. Then we just write hello to call the method, and it will work. Now let's write another module, and we'll define it in a different way. We'll write a goodbye module. Notice we'll just do exports.goodbye, explicitly setting goodbye as a public method. Then inside our app.js, we can require the module and simply call gb.goodbye. Notice in our first module, we can only set one object equal to module.exports. That's going to be the only public method in this module. Whereas with goodbye, we could set multiple methods as public. Lastly, if we wanted to, we could simply call the goodbye method in one line by requiring it and then calling the goodbye method. Let's create another module, this time with 3 functions, foo, bar, and baz. Here you can see them visually represented. Now we want 2 of these methods to be accessible from outside the module. Foo, so we do exports foo equals foo, and bar, so we do exports bar equals bar. Now inside our application, to call these functions, we require the module, and then we can simply call mymod.foo and mymod.bar. Baz, on the other hand, is a private function, which is only available from within the module. Let's write some code to do an HTTP request, and then we'll refactor it into a module. So here you can see we require the HTTP module. The message we'll send into the request is here's looking at you, kid. We'll have a couple options that we'll need to set for the request, the host, the port, the path, and the method. To initialize a request, we'll call HTTP request, we'll send in our options, then we'll pass in a callback function which will be executed when the response returns. Inside of this function, we'll listen for the data event, and we'll specify that when data gets received, we'll simply log it out to the console. Now to write data to the request, we're going to call request.writeMessage. We only want to write one message, so we need to tell the request that it's finished by writing request.end. Let's encapsulate this functionality so we can reuse it by first wrapping it in a function. So in this function, we're going to send in the message, which is going to create the request. Then we can just invoke it by writing make request, here's looking at you, kid. Let's shrink this code, and now we're going to encapsulate this functionality inside of a module. We'll call it makeRequest.js. Remember, to expose this function, we need to write module.exports equals makeRequests. Then, inside of our application, we can require the module and simply make requests. So now let's jump into how exactly require looks for modules. Remember, some of the modules we're using don't have that // so what's going on there? When we require a module using // it's going to look in the same directory as our application for a file with that name, makeRequest.js. If we did // well, it would look up a directory. If we specified an absolute path, well, they would look in that directory as well. Now inside our app, if we just do make request and we don't specify any sort of directory that it might be in, well, it's going to search inside of a Node Modules directory inside of our current app. If it doesn't find it there, well, it's going to go looking for a Node Modules directory in our home directory. Then it'll look inside /home/Node Modules. And lastly, it'll look at the root path. Notice here it's going up one directory at a time looking for that module. Now you might be wondering, do you really put individual files inside these Node Module directories? That might get sloppy after a while, and you would be right. Most of the time when you look inside a Node Modules folder, you're going to see directories. Each directory is a package which represents a module. How do we find out about packages for application, and where do they come from? Well, they come from NPM. If you're familiar with CPAN for Perl or RubyGems for Ruby, well, NPM is where we find packages and modules for Node. It comes with Node. Basically, it's this little command line tool, just like RubyGems. It has a big module repository. That's where you'll be able to search for useful shared open source libraries. There's also really good dependency management built in. So if you have a package and it depends on other packages, well, it's going to go and fetch those when you install that package. It's also easy to publish your own modules, so you can publish your own open source and allow people to reuse your code. npmjs.org is the website if you want to check it out. In our application, we need the request package. In order to install it, we can simply run npm install request, like you see there. This is going to install the request package underneath our application's Node Modules directory. So it's going to create a directory called request and put all the files inside that package inside that directory. Then when we require this module, it's going to go look inside our Node Modules directory, find the package, and include it. Some modules you might want to install globally instead of just underneath your application. For example, here we're installing the CoffeeScript module globally with the -G option. CoffeeScript comes with an executable, so we can run coffee and then specify a file that we want to translate into JavaScript. One thing to note here is that a globally installed module can't be required from inside your application, like you see here. It wouldn't work. In order to do that, we still need to install CoffeeScript, in this case, locally to our application, and then we can require it. So the next time you find yourself coding and thinking, maybe somebody already wrote this code, you might want to head over to the NPM registry. You can search on there for existing shared libraries. You could also go to GitHub and search there, or even on the NPM command line. If you think you might know the name, you can do npm search and then type in the name you think it is or what it does, and you might get lucky and find a shared library. It's a best practice that when you're creating a Node project that you create a package.json file. Inside here, you can specify a lot of options. Here we're going to specify the name of the app, the version of the app, but the most important part here is we're specifying the dependencies, the modules that our application needs to run. Here you can see our application requires the connect module, and we're also specifying the version number that our application needs to run. Once we specify the dependencies, we may want to check that we have all of them installed. We can do that by running npm install. This is going to look inside our package.json file, and if there's any dependencies we don't have in our Node Modules directory, it's going to go fetch them, and in this case, install the connect module. If you start working on somebody else's Node project, it's not going to have a Node Modules directory coming with it, with all the dependencies. So you're going to need to remember to run npm install so that it'll go fetch the dependencies and create that Node Modules directory. Another thing worth noting is if you looked inside that connect folder that was just created, you would see another package.json file. And that might have more dependencies that the connect module depends on. So when you run npm install, it's actually going to go and not only fetch your application's dependencies, but it's going to go fetch those modules' dependencies as well. For example, Connect might go and fetch the QS library, MIME library, and Formidable library, and install that in its own Node modules directory. Before we get into the challenges, we need to make sure everybody understands semantic versioning. This is what NPM uses to version all of their modules. So in our library, we were requiring Connect 1.8.7. That 1 represents a major version of that module. The 8 is a minor version, and the 7 is a patch version. What's the difference? Well, a patch version doesn't change the API, doesn't change the names of the functions you may call. A minor version probably won't. It's a little safer to assume it's not. And then a major version, you can assume will. If you're developing a new app, you might want to make sure you're using the most recent technologies. So in your package.json, you could write something like this, connect and then ~1. What that's going to do is go and fetch the most recent version in between 1.0.0 but less than 2.0.0. Now this of course is going to be a little dangerous because there might be minor versions that break things, but if you're starting an app, you might be able to live on the edge. A little less dangerous, you can specify ~1.8. This would make sure the version is greater or equal to 1.8.0, but less than 1.9.0. The safest way to keep up to date with the most recent patch level would be to specify ~1.8.7, specifying the patch number. In this case, it'll look for versions greater than 1.8.7, but less than 1.9.0. For more information on semantic versioning, check out semver.org.